Today we are going to learn about one more interesting topic, right? What is that interesting topic? Types of enthalpies and changes. What are various types of enthalpy changes? We are going to learn today. Standard enthalpy of formation. First one, let us take, if you carefully observe, standard enthalpy standard enthalpy of changes. In this standard enthalpy of changes, what will happen? Standard enthalpy of formation. What is the equation for that? Delta RH is equivalent to, right? And you know the specific theta like symbol is given now, but it should not be pronounced like a theta. It is not. What is that called? Not. Okay, it is pronounced as a not. Now, what is the importance of this knot? I'll explain in the next class. This knot represents standard state conditions which are defined as a pressure of 100 kilopascals, right? The knot, whatever represented, it is going to be giving a standard measurements or standardized representation conditions for measuring the pressure of gases. Standard enthalpy we are learning now and its formation. Now let us take some examples and definition first. Standard enthalpy is defined as it is the standard enthalpy change for the formation of 1 mole of compound. So for formation of 1 mole of compound, any compound that is, right, formation 1 mole of compound from its elements in their standard state is called as a standard enthalpy formation. Examples for standard enthalpy formation. First one, H2 in the gaseous state plus half O2 in the gaseous state, which gives rise to H2O, right? And delta RH naught is equal to minus 286 kilojoules. Okay, whereas I'm going to take in the second example graphite. Graphite is nothing but a carbon, right? So this graphite or a carbon, when it is going to react with oxygen in the gaseous state, it is going to give you CO2 in the gaseous state as well as delta delta FH delta FH, sorry for this is FH, delta FH naught is equal to minus 393 kilojoules of energy. Third one is, if you take half moles of N2 in the gaseous state, half amount of oxygen in the gaseous state, nitrogen monoxide is going to be taken in the gaseous state. Delta F represents formation and naught, and it is 93 kilojoules of energy. Okay. Now, after standard enthalpy, what we have to learn? A compound formed with the evolution of heat is called an exothermic compound. What do you mean by exothermic compound here? If you carefully learn exothermic compound, the exothermic compound is nothing but a compound formed with evolution of a heat. When the evolution is nothing but transformation from one form to another form, right? The compound is formed due to evolution of heat is called an exothermic compound. Examples for exothermic compounds. First one, CO2 formation, already told you, SO2 formation, water molecule formation, CH4, etc. How they are going to be formed. Now, second one, how? A compound is formed with the absorption of heat, right? If a compound is formed with the absorption of heat, let us take endothermic compound. Endothermic compound is going to be formed from the absorption of a heat. Hence, it is called as endothermic or endothermic. We can say that endothermic compound. Now, you know that delta F H naught, it is nothing but standard enthalpy formation for an element in the standard state. It is arbitrarily taken as 0 in the elemental state. While it was there in the arbitral state, it will be 0. Now, along with that, you know, if delta F H naught value of reactants and products are given, then if the product of standard enthalpy formation sigma bi delta F H naught, and H naught here represent products, right? And also sigma ai delta F H naught, here we are going to take reactants. Okay. Now let us continue second type of enthalpy. First enthalpy I was discussed successfully. Second type of enthalpy, if you take a standard enthalpy of combustion. If you take what is exactly standard enthalpy of combustion. What is exactly standard enthalpy of combustion? It is going to be represented by delta C H naught. Delta C H naught. It is the enthalpy change per mole of substance when it undergoes combustion. When it undergoes combustion, whenever the combustion is going to happen, whenever the combustion is happening, right? So when it undergoes combustion in enthalpy per mole of substance, when it undergoes combustion, all the reactants and products being in their standard state, all the reactants and products, they are going to be in the standard state. What is SS stands for? Standard state. Now let us take examples. Examples are very, very important, right? Example for standard enthalpy of combustion. H2 in the gaseous state, lightweight gas. Half O2 gaseous state, water molecule is going to be formed. In the liquid state finally, a gas can be converted into liquid, right? Faster than anything. Now delta C H naught is equal to minus, what will be the value here? It is equal to minus 286 kilojoules of energy. Here delta C H naught represents enthalpy of combustion of H2, enthalpy of formation of H2O. So what is delta C H naught indicates? It is generally indicating enthalpy of H2 and enthalpy of combustion of enthalpy formation of H2O also. This is also very, very important. And let us take one more example. Second example I am taking here, Roman number 2, and this is Roman number 1. Carbon in the graphite state, capital G I have mentioned, which means it is a graphite. Oxygen O2 in the gaseous state, which is finally going to give you CO2. Here also CO2 formation in the gaseous state, but delta C H naught is equal to minus 393 kilojoules of energy. Third one is carbon is there in the diamond stage, diamond, right? Plus O2 is in the gaseous state, which gives CO2 in the final phase of gaseous state, and delta C H naught is equal to minus 393.5 kilojoules of energy. Delta C H naught is equal to minus 393 kilojoules represents enthalpy of combustion of graphite. So what is this energy indicates? Enthalpy of combustion. So it indicates enthalpy of combustion combustion of graphite. Enthalpy of combustion of graphite. Now these are various reactions I am giving you in the example stage. After that, all combustion reactions are exothermic. Now whatever we learned in the above, all the combustion reactions are exothermic reactions, right? Third type of enthalpy, enthalpy changes during phase transformation. Enthalpy, enthalpy changes. Enthalpy is going to be changes during during phase transformation. During phase transformation, the heat change involved in the change of phase, physical state 1 mole of compound at atmospheric pressure is called as a phase of transition. The heat change, transition is nothing but heat change. When heat change going to occur in the change of phase or physical state, right? So in the change of physical state, when the heat is changed, then it is called enthalpy change during the phase transition. Enthalpy of sublimation. What is exactly enthalpy of sublimation? These shortcuts as well as equations that I am mentioning, you have to take notes and important. Delta sublimation H naught give in the bracket. Next, it is the amount of heat required to convert 1 mole of simple substance in the solid to the gaseous state without decomposition of a substance. So what is enthalpy of sublimation? It is called the amount of heat required. It is nothing but the amount of heat that is going to be required, the amount of heat that is going to be required to convert 1 mole of a simple substance, 1 mole of a simple substance. How it is going to be converted? 1 mole of a simple substance from solid state into the solid state to gaseous state is called as a enthalpy sublimation at 1 bar pressure. It is an endothermic process. It is completely endothermic, right? Now, one more point I would like to tell you. It is generally represented by CO2. How it is going to be generally 195 Kelvin of energy is required. CO2 will be converted into the gaseous state from the solid state when 195 Kelvin energy is applied. Now, delta sublimation here represented as, now you know that one form of compound is transformed into another form because of applying of energy. Such energy is called enthalpy sublimation. Delta sublimation H naught is equal to 25.2 kilojoules mole inverse of energy. Okay. Now B, enthalpy. What is B here? Enthalpy of fusion. If you carefully see enthalpy of fusion, delta Fs H naught, right? It is the amount of heat required to convert 1 mole of solid liquid into 1 bar pressure. So 1 mole of solid or liquid, which is further going to be converted, right, into 1 mole of liquid. It is known as enthalpy of a fusion. It is an endothermic reaction. Example, H2O can be taken, which is in the solid state. It should be converted into H2O, the liquid state, whereas delta fusion H naught is equal to amount of energy plus 6 kilojoules of energy is going to be required. Remaining part I'll continue in the next video. Thank you. Have a nice day.